Today we will cover functions, notation, and evaluating. First we want to talk about evaluate. And when we evaluate, when we're given values for a variable, we're going to substitute and simplify the expression. First example, when x is -2 and y is 3, evaluate 2x plus 5y. My first step, substitution. Last step, do the operations, add -4 plus 15, and my final answer is 11. Next, we're going to evaluate this expression when x is 7 and y is -3. First step, substitution. Substitution, and now we're going to simplify within the absolute value bars. We get -7 plus a -9, which is -16. The absolute value of -16 is +16, and we have evaluated the expression. Next, we notice that we have a quotient here. We're still going to simplify, substitute, and we're going to substitute everywhere we see an x, we're going to put in -1/2. And everywhere we see a y, we're going to put in 2. So what we're going to do is we're going to get a value for our numerator, and we're going to get a value for our denominator. And in the last step, we're going to divide those two. So here we have a -2 times a -1. A negative times a negative is a positive, and that's going to give us 1. We multiply it by 2, and then we subtract 4. When we do that, we get -2 over 7, and that's our final answer. Next, we're going to review order of operations. We're going to do parentheses or groups first. Next, we're going to do exponents. We will do multiplication and division from left to right, whichever one comes first. And then we will do addition and subtraction. Let's go ahead and scratch that out. So as we look at this slide, I see that the notes, I need to make a small adjustment. This right here should be 3 to the second power. It didn't come out correctly. Let's see if anything else needs to be adjusted. There we have it, and this one should be 2 to the third power. Sometimes when you go from PowerPoint to video, the scripts and subscripts and superscripts don't always come out correctly. Hit pause and evaluate the function. So when we evaluate this first function and expression, and we do 4 plus 3 squared, we get 13. We have to do the division first. So 13 divided by 13 is 1, and 7 minus 1 is 6. In this next one, order of operations, we would do this in parentheses first. But by the time we multiply everything by 0, guess what the final answer is? It is 0. Take a look at this last one. We have to do this in parentheses first. And 25 divided by 5 is going to be 5. So we get 2 plus 5. And inside parentheses, we have 5. 2 to the third power is 8. And 2 times 3 is 6. Still have to simplify what's in parentheses first. And we have 5 minus 8 is -3. And a -3 plus 6 is going to give us a +3. So this becomes 2 plus 5 times 3. Final answer, 15 plus 2, which is 17. Okay, so we evaluated some expressions. Let's evaluate some functions now. So the definition of a relation is a relationship between a set of information, typically between your inputs and your outputs, your x's and your y's. Now, in order for one to be a function here, a function is a relation such that there is no more than one output for each input. What am I saying here? I'm saying that the x's cannot repeat in order to be a function. So let's take a look at some examples of functions. X's can't repeat, so let's just look at the values for our x's or our domain, 10, 15, 18, 27. No repeats is fine. When I look at the y's, they repeat, but that's not the qualification for being a function. We just look at the x's. Take a look at this table here. I have -3, -1, 0, 5, 7. My x's did not repeat. Therefore, this is a function and this is a function. However, we should be able to look at a graph and determine if it is a function. So what we want to do is we want to make sure there's only one x value for every y value. So when I look at this point right here, it's only one x value. So as I travel up this line, I'm crossing one x value at a time. So guess what? This is a function. Take a look at this one here. This is my graph right here. And as I travel along here, I only cross one x value at a time. In order to figure out what a function is, let's talk about what a function is not. So here's a graph right here. And here is a circle. Now, as I cross and go over my x-axis, I cross two x values here. So take a look at the two x values. This would be an x value right here on the circle, and this would be an x value right here on the circle. It would be the same x value. So this is not a function. Okay? So if you take your pencil or vertical line and cross it, and you happen to hit two x values, if you were to write out the coordinates, that means it's not a function. So that's a vertical line test, which is one of the things that you can do to check to see if it's a function. Here are examples of non-functions. Why is this table not a function? Oh, because we have two ones and x values repeat. Why isn't this one a function? Oh, we have this point and this point. They are both x values. This point right here is -4, 1, and this point right here is -4, 7. So this is not a function. Here we see the graph. However, take a look. This x value here and this x value here repeat, and so it's not a function. And look at it. It fails my vertical line test. So when we talk about evaluating functions, we need to know about function notation. So the f is the name of the function, like the function machine, and the value inside the parentheses is going to be the input. The expression to the right of the equal sign shows what the machine does to the input. So which do you prefer? The notation where we say f of 25, or do you like when we say evaluate f when x is 25? Because basically it's the same thing. We're going to drop in a 25 and we drop it into the square root. We crunch it through the machine and the square root of 25 comes out as, you got it, 5. Here's another example right here. It says f of x is equal to 2x plus 3. We need to find f of 5. So everywhere we see an x, we're going to replace it with the 5. So this becomes 2 times 5 plus 3. On the next line, following order of operations, 2 times 5 is 10, plus 3 is 13. So when we put in a 5, we get out a 13. So take a look at this. The fraction one. We have -2/3 x plus 3. And what we're going to do is we're going to evaluate f of 3. What does that mean? Substitute and evaluate. So everywhere we see an x, we're going to drop in a 3. So -2/3 times 3. Then we add 3. This gives us -2 plus 3, which gives us 1. We could switch up the directions and say, find x if f of x is equal to -5. So solve for x when the output is -5. So we're going to rewrite this. Instead of putting f of x is equal to -2/3 x plus 3, we're going to substitute -5 in for our y value. And then we're going to solve. -5 is equal to -2/3 x plus 3. We subtract 3 on each side and get -x is equal to -2/3x. We multiply both sides by 3 to get rid of the denominator. And then we go back and divide by -2. And we get x is equal to 12. So let's do a quick lesson summary. How do you know if it's a function using a table? You got it. The x's can't repeat. How do you know if it's a function using a graph? How do you know if it's a function using a graph that's provided? Well, the x's still can't repeat. However, we could do a vertical line test to make sure the x's don't repeat. How do we evaluate? Well, we substitute the values and simplify. And that concludes our lesson. Thank you.